Example 20, I give you 30 seconds to read the question. Okay, right. A ball is falling vertically downwards from a height, right? And each time a ball falls vertically onto a horizontal floor, it rebounds, right? But you know that, from we all have experienced bouncing ball, right? When you drop a ball, it's not going to bounce higher or unless you exert some force, right? If you just let it drop freely, when it rebounds, it's not going to reach the same height as where you drop, right? It's going to get lower and lower and lower, and eventually you will stop. So this is like, when you drop, it hit the floor, rebounds, it's going to hit certain height, but this height is not going to reach the same height, right? Because of energy loss and so on, right? So it's going to keep lowering, bouncing lower and lower and lower, and eventually it's going to stop, right? So what does the question say? It is initially dropped from a place 4 meters from the floor, and find the total distance, vertical distance the ball travels until it is about to touch the floor on the first, second, third, fourth, and nth time. You may assume that the ball has negligible dimensions, right? Okay. So you see, when over here it says that when it rebounds to 3/4 of the height from which it fell. So first it says that it starts from 4 meter. It starts from 4 meter. Second time, what is the height then? It's actually 3/4 of 4 meter. Can you see that? Right? Because it says that when you rebound, it can only reach 3/4 of its original height, the previous height. Okay. So then after that, when it hit the floor again, when you rebound, it will be 3/4 of the previous height. What is the previous height? 3/4 of previous height is this 3/4 of 4. Can you see that? Okay. So it's actually equals to 3/4 squared times 4. Can you see now? Okay, so this is like, can you see that it's a GP in action? Right, from 4, okay, we are now talking only the heights. 4, you'll be 4 times 3/4, then 4 times 3/4 square. Then of course over here, the third time when it bounce, after the third bounce, it will only reach a height of 4 times 3/4 cube. Okay, so roughly, okay, this is how we can try to understand what the question is saying. Okay, so now the question says that they want the distance that the ball traveled from up from the when it touched the first bounce, second bounce, third bounce, and fourth bounce. Okay, so what is the difference between the first bounce and the second bounce? The first bounce is like from the height, you just travel about 4 meter, right? 4 meter vertical distance. But the second bounce, between the first bounce and second bounce, is not 3/4 times 4. In fact, it's 2 times. Can you see that? You need to go up and come down. So it's 2 times or 3/4 times 4. Subsequent ones, so subsequent in between subsequent bounces, the distance traveled is 2 times the height that it attained. Right? Only the first one doesn't double because it doesn't start from 0. It actually start from the top. Okay, so with this, for this type of questions, so it's easy for us to set up a table to present the solution. Okay, so the total distance in meter traveled upon the K bounce, right? Or like just before the K bounce, just before one. So just before the first bounce, this is the first bounce. This is the second bounce, right? This is a third bounce, okay? And then of course it's fourth and so on. Da, da, da. Okay, so the first bounce is 4. Second bounce will be 4 plus 3/4 times 4. Okay, so first bounce is 4. Second bounce is 3/4 times 4 times 2 because this one is only like that, right? Okay, this one is like that, 2 times, right? Then this one will be 1, 2, 3, right? Third bounce. Okay, so that's why you have 4 plus 2 times 2 times of 4 times 3/4. This is 2 times of 4 times 3/4 square, and so on. So from here, now, if you look at the questions, the question only asks for total distance traveled, right? Okay, and so over here we, for us, okay, for us, we do not want to, do not unless the question asks for the exact the values, otherwise we do not need to simplify the expression so that we can see the pattern, right? So you can observe that the first bounce is 4, second bounce is 4 plus first term of a GP, third bounce is 4 plus two terms of a GP, fourth bounce is first term plus three terms of the GP, and so on. So how? So when you reach the end bounce, you have to see the pattern now. Okay, so you will start with, okay, so you look at, okay, 4, everyone start with 4, so I will also start with 4 here. So I will have a 4 plus up. So just before end bounce, this is the distance that you have traveled. Okay, so you'll be 4 plus 2 times 4 times of 3/4, right? This is the first bounce, this is the second bounce. Then third bounce is 2 times 4 times 3/4 square, right? Fourth bounce is this, and so on. Okay, so I write one more, 2 times 4 to the plus multiply by 3/4 cube, right? Okay, so where do I stop? So we know that it's going to look something, we know that the last term will look something like this, 2 times 4 times 3/4 to the power of something, right? So what is this? How to figure out what is the power then? Okay, so you can see that when k is equals to 2, this is 1, right? When k is equals to 3, the power is 2. When k is equals to 4, the power is 3. So you see, this power is always 1 less than k. Can you see that? So when k is n, what is the power here then? The power here is n minus 1. Okay, so now if you were to simplify, you know that all these are equals to 8. We can factor out the 8. So you can see that it is actually equals to 4 plus 8 with a sum of a GP. So what is this sum of GP then? To find the sum of GP, we know that S of n is equals to A multiplied by 1 minus R to the n divided by 1 minus R. Okay, so we need to know what is A, what is R, and what is n. Okay, so A first term is 3/4, no problem. And what is R? R is, you can see that each time I multiply 3/4. So the common ratio is also 3/4. Then what is the number of terms? Okay, so you see, I start counting from 1, 2, 3. If I tell you ask to count 1 to 100, how many terms are there? Of course 100. 1 to 50, of course is 50 term. 1 to 21, of course 21 term. 1 to n minus 1, of course is n minus 1 terms. Okay, so this n is number of terms. It's different from this n. Okay, when I say n here, this is number of terms. Okay, so in maybe I shouldn't use n, I should just say number of terms, right, equals to n minus 1. But in the formula, we will use n to represent the number of terms. So you apply all this into this formula. So you have 4 plus 8 multiplied by A multiplied by 1 minus R to the power of n minus 1, right? This n minus 1 is the number of terms. Okay, then divide by 1 minus the ratio. And after that, of course, you can simplify all these algebraic manipulations. Then this will be the final answer. Okay, next. Okay, so we are done with the first part, right? Next, using your expressions for the nth time, find the number of times the ball has bounced on the floor when it has traveled 24 meters. Okay, you will not be so accurate that when you reach here, you will reach this bounce and then wow, just enough cover 24 meters. No, it could be more. Okay, this one could be more. Maybe the 24 meter when you reach here is exactly 24 already. So it doesn't matter. So we just need to make sure that when I hit bounce, just before I bounce, it is more than or equals to 24. That's good enough. Okay, so basically we want the sum of n term, okay, is, or sum of n term is greater or equals to 24. Okay, so what we can do is we just say that at the n term, total distance is less than or equals to 24. Okay, why have to put equal? Very unlikely that it's going to be equal 24. Okay, so but for proper inequality. It is what happened if it's like so lucky that it's 24. You have to take the n to be the answer. So when you do the inequality without you, if you don't put the equal, actually it's wrong. Okay, so we have to use less than or equal. And when you have so we try to simplify this expression. So you bring this term, add this term to both sides, and then you bring the 24 across, so you get 28 minus 24 divided by 24, so you get 3 quarter to the power of n minus 1 greater or equals to 1 over 6. So again, we have rational exponential function. So what do? You take ln of both sides, and you bring down the n minus 1 power, which is n minus 1. And next, we need to divide by ln of 3 quarter. So again, ln of 3 quarter less than 3 quarter is less than 1. So this is a negative number, right? So when you want to divide by a negative number, what must you do? You must change the inequality sign. Okay, so just remember, okay, this one, can you please go and highlight, right? Because this is a negative number, I must change the inequality sign. Okay, then this value here is actually ln of 1 over 6 divided by ln of 3 quarter lah, right? Okay, then after that, after you got the answer, of course you need to plus 1 on both sides, then you get n is less than or equals to 7.23. So what is the largest integer that is less than 7.23? It will be 7. Okay, so you see, that means it has, the ball has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. After that, when you reach here, okay, this is where they hit 24 meter. Can you see that? Already bounced 7 times. Okay, that's what it means. Okay, so what's the theoretical total distance? So okay, let's go and look at the picture again. Okay, we know that if I were to drop a ball, the ball will bounce, eventually it's going to stay still already. It's not going to bounce anymore. But mathematically, in theory, the ball actually will continue bouncing forever. No, you cannot see, but it's actually vibrating. Okay, but we know that in real life that's not possible lah. Okay, but this is a mathematical model. Is in theory. Okay, but what is the total distance traveled? Total distance traveled is actually the sum to infinity. Imagine that the ball bounce infinitely many times, right? So now we look at this expression. Okay, as n tends to infinity, what happened? As n tends to infinity, this expression will tend to, as n tends to infinity, 3 quarter to the power of n minus 1 will tend to 0. So this whole expression, okay, let me erase this, confusing. Okay, this whole expression will be gone because 3 quarter to the power of n minus 1 tend to 0. So the total distance traveled will tends to 28. Okay, that's what it means. Okay, so the theoretical total vertical distance traveled before coming to rest, right, is equal to the limit of the total distance limit, or you can look at it as the sum to infinity, which is 28 meter. Okay, you can try using finding this a over 1 minus r, you get 28 also, right? That is the theoretical limit.